All right, so we're doing part 2 of the notes in part 1, meaning download the notes and then scroll down to the last 3 slides because we're a little short on time today because it's a shorter period. So it's easier to get this out of the way, and then tomorrow we'll spend the class period doing the beginning part. So this is your 2.6 notes. Scroll all the way down to the end, the last 3 slides. We're going to talk about functions being even, odd, or neither. All right, there's 2 ways that we talk about even, odd, neither. 2 ways to talk about even, odd, neither. Graphically, which means you're looking at a graph, or algebraically, which means you're going to figure out the answer using algebra, using numbers. All right, graphically and algebraically, this is what the book tells us. Let f be a function. If it's even, then f of negative x is equal to f of x. Okay, if it's odd, f of negative x is equal to negative f of x. Right? Does that make perfect sense to everyone? Probably not. Okay, so now we're going to talk about, in layman's terms, how Mrs. Meadows would describe it. Okay, and I have a different way to do it algebraically as well. But graphically, guys, a function is even if the direction of the arrows are the same, if the arrows are going in the same direction, and it's symmetric to the y-axis. What does that mean? The y-axis does what? Cuts it in half, okay? If the function is odd, then the arrows are going in opposite directions, and it has to go through the origin. It has to do both of those things if it's even, or both if it's odd, not just one. If it doesn't do both things and you think it's even, and it doesn't do both things and you think it's odd, then it's neither. So if you're looking at a graph, this is how I always tell everybody to go through the motions. First thing you do is you look at the ends of the graph. Look at the ends. Are they going in the same direction? Or are they going in opposite directions? They're going in the same, okay? So this function could possibly be what? Even. The other thing that has to happen in order for this to be even is the y-axis has to cut it in half. Does it? Yes. So then this is an even function. It's literally that simple for looking at it graphically. If you look at this next one, look at the ends. What do you notice about the ends? They go in the same direction or opposite? Opposite, okay? In order for it to be an odd function, the arrows have to be going in the opposite direction, which they are, and it has to do what? Go through the origin. Does it? Yes. So this is an odd function. All right, does that make sense? All right, if you guys scroll to 2 slides down, in order, this is the last slide. Graphically, you guys will have a question on your quiz, and it's going to say, is this function even, odd, or neither? The way that you tell that, the first thing we do, we're going to go through the motions. What do? We look at the ends of the graph. Are they going in the same direction or opposite directions? Opposite, okay? So I think it could be an odd function because they're going in opposite directions. They're going in opposite directions. What else has to happen in order for this to be an odd function? Has to go through the origin, does it? Then you have shown me that this is an odd function. Say they were in opposite directions, but it didn't go through the origin. You tell me it's neither. All right, let's look at the second example. Look at the ends. Same or opposite? They're going in the same direction. Okay, great. Doesn't matter that they're both going down. They're just going in the same direction. So if you think it's an even function, same direction, and the y-axis does what? Cuts it in half. Does it? Yes. So this is an even function. That makes sense. You guys all right? All right, look at the last one. Look at the ends. Same or opposite? Same. Okay, so then I think it might be what? Even. So does the y-axis cut it in half? No. So your answer here is neither. Notice, guys, in this one, what does it go through? The origin. So this one, you can't be like, oh, well, it might be odd. It's not odd. If it's odd, the arrows have to go in what? Opposite directions. It has to do both things, not one or one of each. Everybody with me? All right. Let's move along to algebraically then. Algebraically. Okay, now, I'm going to do a problem right now, and I don't want you to copy it down. just want you to watch. That first statement that I said, if something is even, then f negative x equals f of x, and if it's odd, then f of negative x equals negative f of x. What you want to do algebraically is you look here. The first thing we're going to do is, okay, this is the function I'm talking about. Right? We identify the highest exponent. What is the highest exponent? 5. What kind of a number is 5? It's odd. So your function could be one of two things. If the highest exponent is odd, it's either an odd function or a neither function. If the highest exponent is an even number, then it's either even or neither. It can't be even or odd. It's not like that. So you would take a negative x, right? So I'm going to plug in negative x to the 5th plus negative x. So if I simplify this, I have negative x to the 5th minus x. Compare these two. Are they exact opposites of each other? Yes. Do you see how this is positive x to the 5th? This is negative x to the 5th. This is a positive x. This is a negative x. So you just algebraically proved that this was an odd function. I think for some of us that is very hard to see. You guys are like, what? I don't know. This could be kind of confusing. All right, so let me give you an easier way to do this. We're going to use the same process, but instead of x's, we're going to use numbers. You can pick any number you want, bigger than 1. So 2 or higher, and its exact opposite. I'm going to do the first example with 2 different numbers, and I'll show you why this will work all the time. So everybody with me. Number or letter A. It's f of x equals x to the 5th plus x, right? This is how you guys are going to show me your work on your quiz. This is how you guys are we're going to do this more than just once. But I say, okay, what is the highest exponent I see? A 5. What kind of a number is 5? So I can either have, this is either an odd function or a neither function. So this is how I want you guys to set your problem up. If I think my function is odd, what is the direction of the arrows? The same or opposite? So I'm going to write that right here. Very important step. Okay, so pick any number bigger than 1 and its opposite. I'm going to say positive 2 and negative 2. So I'm going to plug in negative 2 and I'm going to plug in positive 2. It doesn't matter which side you do it on. Just pay attention to your sign. So when I plug in negative 2, I have negative 2 to the 5th power plus negative 2. What is negative 2 to the 5th power? Negative 32 minus 2 is what? Negative 34. Okay? Deal? Mm-hmm. So now on the right-hand side, I'm going to do positive 2. So I would put everything in parentheses so you don't miss a negative sign. But 2 to the 5th power plus 2. Well, 2 to the 5th power is 32 plus 2 is what? 34. Are those two numbers exact opposites? So then this is an odd function. To me, that is easier to compare, to see, are these exact opposites of each other? Are they close? It's easier to use numbers. I'll do the same example, but look, let's plug in 3 and negative 3. So if I have negative 3 and I have positive 3. So you have, what, negative 3 to the 5th power plus a negative 3. And I have 3 to the 5th power plus 3. So I have negative 243 minus 3 is negative 246, right? So over here I have 243 plus 3 gives me positive 246. What is the relationship between negative 246 and positive 246? They're what? Are they opposites? Yeah. So then it's an odd function. I'm not concerned too much about what your numerical answer is you want to compare the relationship between the two answers. All right, let's look at B. What does B say? 1 minus x to the 4th. Okay. All right, so let's go through the process. Good. The first thing we do is identify the highest exponent. It's not always the first one. You want to find the highest one. So what's the highest exponent you see? 4. 4. What kind of a number is 4? Even. It's even. So your function could be one of two things, either even or neither. So get your problem set up. What number are we going to use? What do you guys want to do? 2 and negative 2? Perfect. You can do that every single time. What number am I going to write? I mean, what letter, what word am I going to write between those two boxes? Not even. What do I know about the directions of the arrow? Same. It practically tells you your answer when you write that word in between. So we're going to do 2 and negative 2. 2 and negative 2. It doesn't matter which side you do, the negative or the positive. So I have 1 minus negative 2 to the 4th. Evaluate the power. Negative 2 to the 4th is?
16.
So 1 minus 16 gives me negative 15. So over here on the right, I'm going to plug in positive 2. So 1 minus 2 to the 4th power. Do your power first. What's 2 to the 4th power? 1 minus 16 is negative 15. Are those two numbers exactly the same?
Yes.
So then what kind of a function do you have? There you go. Now, if you're more comfortable with plugging in x and negative x, feel free. That is totally fine. I just think it's easier for us to see stuff if we have numbers in front of us. It's just, we think better in numbers. All right, let's look at the last one. And then I have 2 more examples on the next that I want to do. h of x equals 2x minus x squared. Okay, this is like what I was telling you guys. Don't just automatically look at the first exponent. Because the first exponent right here is a 1. That's an odd number. You don't want to look at the first one. You want to look at the what? The highest. What is the highest exponent you see? A 2. What kind of a number is 2? Even. So your choices are either even or neither. Again, you guys want to use 2, negative 2? That's fine. If it's an even function, what do you know about the arrows? They're the same, so then your answers here should be the same. So negative 2 and positive 2. Perfect. So I have 2. I'm going to plug in negative 2 minus negative 2 squared. I would put everything in parentheses so you guys don't miss signs. God bless you. All right. So what is 2 times negative 2? God bless you. Negative 4, right? Minus, what is negative 2 squared? 4. What is negative 4 minus 4? Negative 8. Good. You're fine. Okay, over here on the right, we're going to do the same thing. I'm going to plug in a positive 2. So 2 times 2 minus 2 squared. What's 2 times 2? 4 minus, what's 2 squared? 4. Bella, what's 4 minus 4? 0. Are those two numbers the same? So what's your answer? Neither. Good job. Again, if you are prone to wanting to plug in x and negative x, you're more than welcome to. I just think it's easier doing it. Let's look at these two. Take a picture of them, copy them down. I want to do these two, and then we're done. All right, let's look at the first one. Let's go through the motions. What's the first thing I do? I look at the biggest exponent. What is the biggest exponent? 3. What kind of a number is 3? Odd. So this is either odd or neither. So get your problem set up. What word is going to go in between my two answers? Opposite. Very good. These need to be exact opposites of each other. What number do we want to use? 2 and negative 2. Okay, so negative 2 and positive 2. So I have 2 times negative 2 squared. Thank you. 3 times negative 2 cubed. Lots of 2's and 3's in there. So when we go through and evaluate, guys, excuse me, what is negative 2 cubed? Negative 8, right? Negative 3 times negative 8 is positive 24. Over here, I have negative 2 squared is 4, and 4 times 2 is 8, right? Yes? So 8 and 24? 32. Thank you, sir. All right, now on the right, I'm going to plug in a positive 2. So I have 2 times 2 squared minus 3 times 2 cubed. Well, 2 cubed is 8. Negative 3 times 8 is negative 24. Over here, 2 squared is 4, and 4 times 2 is 8. What's 8 minus 24? What's 8 minus 24? What kind of 16? Negative 16. Are those two numbers exact opposites of each other? No. They're opposite signs, yeah, but are they exact opposite numbers? No, they are not. So what is your answer here? Neither. Good. This is a neither function. Yeah, because we're going to do another one. Now, again, if you were going to plug in x and negative x, if you notice here, do you guys see how here I have positive 24 and here I have negative 24? Those are opposites of each other. But notice the 8s are both positive. So part of your function would be opposite and part of it wouldn't be. So that's why it would be a neither function. I just think it's easier to use numbers. Let's go over here to this one. All right. Identify the highest exponent. What's the highest exponent you see? A 4. What kind of a number is 4? Even. So this function is either even or neither. Now you can use any number you want and its exact opposite. It just has to be bigger than 1, so 2 or higher. I always use 2. But if I think this is an even function, what is the direction of the arrows? The same. So when algebraically I work this out, these answers should be exactly the same. So if I plug in negative 2 and positive 2, I have negative 3 times negative 2 squared plus 1/2 times negative 2 to the 4th. So let's do our squaring first. Negative 2 squared is 4, so you have negative 3 times 4 plus 1/2 times, what's negative 2 to the 4th power? 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, so negative 3 times 4 is negative 12. 16 times 1/2 is plus 8. So negative 12 plus 8 is what number? Negative 4. Good. Okay, a little bit of math there. No biggie. Now on the right-hand side, we're going to do the exact same thing, but we're going to plug in positive 2. So negative 3 times 2 squared plus 1/2 times 2 to the 4th. 2 squared is 4, so you have negative 3 times 4 plus 1/2 times 2 to the 4th power is 16. So you have negative 12 plus 8. What is negative 12 plus 8? Negative 4. Are those two numbers exactly the same? So your function is even. Opposite. And it's all based upon your highest exponent. And then like here, right, we saw the highest exponent was a 3. So when we worked it out, they should have been opposite of each other. And since they're not, then you're good. All right, so guys, just for a second, all right, take your mind out of this problem. Pretend that we got this as our answer. Positive 4 and negative 4. Right? Our highest exponent was an even number, so we said they were going to be the same. Is positive 4 and negative 4 the exact same thing? No, they're opposites of each other, right? So does that now make this function odd? No. If the highest exponent is even, the only two options are even or neither. If for some reason the number that you picked and its exact opposite, you work it out and they're odd, then that just means neither. That does not mean that, oh wait, it just switched from I thought it was even to now it could possibly be an odd. That's why it's really important at the beginning to identify what the highest exponent is, and then you recognize, okay, it can either be even or neither, or odd or neither. It can never be even or odd when you're working algebraically. So just make sure you guys are aware of that. We got negative 4 on both of these. All right, we're good? Okay, tomorrow we're going to do the second part, which is the longer part, talking about shifting graphs. Up, down, left, right, shrinking, expanding, all those sorts of things.